Okay, let's dive right into this. Welcome everyone to today's Explainer. If you're a focused learner trying to figure out what is really happening beneath the surface of this massive AI boom, you are in the exact right place. Today, we're demystifying the AI gold rush through a super fascinating lens, the 15-year tech journey of Grigory Margushak, the founder of SafeBots. We're going to explore how one developer spent over a decade quietly building the infrastructure for community sovereignty, and how that put him in the absolute perfect position to solve one of the most terrifying security crises in the enterprise AI space today. We've got a ton of ground to cover, so let's just get right to it.
So, vibe coding. It's a huge buzzword right now, isn't it? And honestly, it perfectly captures the kind of chaotic nature of this specific moment in tech. Vibe coding basically means sitting down with an AI, feeling out the general shape of what you want, and letting the model just fill in the blanks. Notice the key concept there, drifting. People are literally just gesturing at what they want and letting the current of the AI take them wherever. But I gotta give you a massive warning here. Drifting is incredibly dangerous, especially when that AI is suddenly capable of moving actual money, deleting production data, or deploying live code to thousands of users. Actions in the real world have massive consequences, and you just cannot drift your way out of them.
And this brilliantly illustrates the exact opposite approach, the approach that is absolutely required for true, secure development. On one side, you've got drifting, that vibe coding we just talked about. It generates code that looks highly plausible but is completely wrong, leaving your systems wide open to catastrophic errors. But on the flip side, you have managing. This means treating the AI like an extraordinarily fast, highly capable subordinate. It requires expert direction. It requires you, the human, to review the output and catch the mistakes before they snowball. Because without a manager who actually understands the technical territory, a lightning-fast AI isn't some miracle worker. It just becomes a terrifyingly fast generator of absolute chaos.
Moving on to Section 1, the 15-year substrate, bootstrapping a paradigm shift.
Look, truly safe, manageable AI isn't just built overnight on a whim. It takes a solid foundation, a substrate. Margushak actually spent over a decade bootstrapping the infrastructure for this exact paradigm shift, way before AI was dominating our social feeds. Back in 2011, he started building the Cubics open-source platform, envisioning an internet where communities actually owned their own data. Then, from 2014 to 2018, his team shipped the Groups app, scaling it up to over 7 million users globally. Wow, right? Fast forward to between 2019 and 2022, they deployed robust smart contracts across 8 different blockchain mainnets to manage community economies, completely free from corporate overlords. All of this represents a 15-year, largely unfunded substrate of secure, decentralized, battle-tested infrastructure. It was just sitting there, accumulating strength, totally ready for February 2026, which is when an intense 3-month AI sprint finally kicked off.
That brings us to Section 2, the catalyst and the sprint, a security wake-up call. Now, what's really interesting about this is what actually happened in 2026 to kickstart that massive sprint. Well, while the founder was quietly building a secure substrate, a massive inciting incident blew up in the wider tech world. 180,000. That staggering number? That represents the viral GitHub stars for a side project called OpenClaw. OpenClaw was basically a personal AI agent you could run right on your laptop, plugged directly into your messages and your files. It exploded. But here's the crazy part. It was secretly running inside major enterprises that had never even authorized it. It went so viral that OpenAI actually stepped in and bought it, essentially kicking off a massive bidding war for the developer.
But behind all that hype, the reality of OpenClaw was a total nightmare. API keys stored in plain text. It had completely unauthenticated WebSockets. It was actively leaking Anthropic keys, plus Slack and Telegram tokens, to literally anyone on the internet who bothered to scan for them. Thousands of instances were exposed in just a matter of hours. It was an absolute disaster that proved exactly why meticulous, secure foundational work is non-negotiable. This whole mess exposed a massive structural problem the AI industry was desperately trying to ignore. Listen, chief security officers absolutely cannot accept a flimsy, just trust us promise from these AI labs. They desperately need a real cryptographic attestation layer before they'll even think about deploying autonomous agents on sensitive enterprise data.
Which leads us to Section 3, the SafeBox stack explained. Cryptographic proof versus trust us. That massive security gap we just talked about, that is exactly what triggered Margushak's grueling 3-month sprint. Working side by side with the AI model Claude as his execution partner, he leveraged that 15-year substrate to ship 4 interlocking systems. The goal? To replace that terrible trust us model with absolute cryptographic proof. First up is SafeBox itself. Think of this like a mathematically sealed digital vault. It is a completely locked-down execution environment running inside a hardware-attested enclave. What that means is it guarantees, mathematically, that the operator running the AI can never, ever see your plain text data. No backdoors, no loopholes. It keeps your cryptographic identity entirely safe. Building directly on top of that, we have SafeBots. Think of this as the governance layer. Because you can't just have an AI running wild doing whatever it wants. You need strict rules. SafeBots requires multi-party approval. It enforces role-based capabilities, and it generates absolutely flawless audit trails. This specific piece right here is what transforms an autonomous AI from being a massive, terrifying corporate liability into a highly regulated, fully compliant tool that a chief security officer can actually look at and sign off on.
Next in the stack is Grokers, and this is just brilliant. It's an autonomous comprehension system. So instead of the AI starting completely from scratch every single time it looks at your software, Grokers parses the code base and builds this persistent semantic map. It basically gives the AI a long-term working memory of incredibly complex code bases, even ones spanning multiple different programming languages.
And finally, the fourth piece, code. Now, this was born from a massive aha moment during an actual argument between the founder and the AI. They realized that coding itself is fundamentally just a workflow. By treating code changes as workflows and using ZFS file system forks as workspaces, which is essentially creating these safe parallel universes for code, multiple AI agents can work at the exact same time without any of that messy merge contention. It's so efficient that it allowed the stack to essentially eat itself. They used this exact workflow tool to rapidly build out the rest of the infrastructure.
Section 4, AI as a 50x partner, the multiplier effect.
So the crucial point here is, what is the actual day-to-day experience of building a massive stack like this using Claude? It raises this super fascinating question. What kind of speed is actually possible when a founder who deeply, truly understands their own architecture uses AI as a legitimate partner? 50x, no joke. We hear a ton of mythology in tech about the elusive 10x developer, but Margashok found that with AI as a serious execution partner, working on an underlying substrate that you actually built and own yourself, the multiplier is much closer to 50x. Honestly, on the best days, maybe even higher than that.
But listen, that 50x multiplier, that does not happen by accident. For this to actually work, you have to already know the shape of the answer to guide the AI, simply because the model constantly forgets context, kind of like an overeager intern, right? You have to actively argue and push back, because the AI is frequently incredibly confident even when it's completely horribly wrong. And most importantly, you have to own that underlying substrate yourself so you can instantly verify the code it gives you. If you don't aggressively manage the model's total lack of restraint, well, that 50x multiplier vanishes in a puff of smoke, and your AI just turns into a 50x bug generator. Like we said earlier, management is literally everything. And finally, Section 5, Architecting a Safer Future, Digital Sovereignty. Let's bring all of these deep technical concepts directly back to you, to your personal digital life, and why this all actually matters for the future of our society. There's a quote that perfectly sums it up. Web3 handed the world programmable money and got back, mostly, casinos, though the underlying decentralization principle was the right one. Really think about it. Web 2 handed total control of our public square over to 5 massive companies, and we're definitely still dealing with the fallout of that today. Both of those previous tech eras failed because secure, community-owned infrastructure was treated like an afterthought. Now, AI is exponentially more powerful than Web 2 or Web 3 ever were. Its failure modes, they're going to be vastly more severe. If we don't start building verifiable, decentralized systems like SafeBox right now, the consequences are going to be disastrous.
Which leaves us with one incredibly vital question to ponder. As we rapidly approach the era of autonomous AI, who are you actually trusting with your digital sovereignty and your data? Are you really willing to hand over your entire digital life based on a flimsy corporate promise of just trust us? Or do you want a future that's built on undeniable cryptographic proof and real community ownership? That is the exact choice we are facing right now. And the good news is, the infrastructure to make the right choice is finally being built. Thank you so much for joining me for this explainer. Keep asking those hard questions and keep learning.